Hi everyone, I am Sir Richard and I will be joining you in this video lesson. Let us begin. Our topic is solving problems involving kites. For our review, let us have activity 1. True or false. Write P if the statement is true and F if false. For the first number, a kite is a quadrilateral with two distinct pairs of congruent adjacent sides. Is it true or false? The answer, true. Number 2, the diagonals of a kite are perpendicular. The answer, true. Number 3, opposite angles of a kite are congruent. That is false. Number 4, a kite is a parallelogram. The answer is false. Number 5, consecutive angles of a parallelogram are supplementary. That is false. Okay? Let's now proceed with our main discussion. Please take note of the following. Kites definition. A quadrilateral with two pairs of adjacent and congruent sides. So quadrilateral KITE is a kite given that KE is congruent to TE and KI is congruent to TI. Now, let us have some review and recap of our properties. Opposite angles at the endpoints of the cross diagonal, which is KT in the figure, are congruent. So that means angle K is congruent to angle T. The main diagonal, which is IE in the figure, bisects a pair of opposite angles. So with that, angle KEI is congruent to angle TEI. Also, angle KIE is congruent to angle TIE. In a kite, the perpendicular bisector of at least one diagonal is the other diagonal. That is, IE is the perpendicular bisector of KT. So, this segment IE or diagonal IE bisects KT into two equal parts. The area of a kite is half the product of the lengths of its diagonals. So that means the area of KITE is given by the formula A equals 1/2 of the product of IE times KT. That's it. I hope somehow we have recalled this concept that will be applied in our problems in a while. Let us have our example. In solving problems involving kites, we need to keep in mind its properties. So in the figure, we have kite LONE. We are now asked to solve the following. So applying our properties to answer these questions, let us begin with number 1. If EL is equal to 4, then LO is equal to blank. So EL is given, which is 4 units, and we are asked to solve for LO. So the property that can be used to solve this will be a quadrilateral with two pairs of adjacent and congruent sides. So that means EL is congruent to LO. With that, LO will be equal to 4 also. Next, let us have number 2. If NO is equal to 14 units, then NE is equal to blank. So again, the given is NO, which is 14, and we are asked to solve for the length of NE. So I guess it's just the same with number 1. So the answer will just be 14 also. Let us have number 3. If NL is equal to 13 and the length of OE is 8, what is its area? So the given NL and OE are the diagonals of the kite. So we are going to use the property, or the area of a kite is half the product of the lengths of its diagonals. So with that, we are going to use the formula A is equal to 1/2 times the first diagonal times the second diagonal, or let's say NL times OE. Substituting our given, we have A equals 1/2 of 13 times 8. And our answer, 52 square units. Let us have number 4. If the area is 96 square centimeters and OE is 3 centimeters, what is the length of LN? So in this item, the area of a kite is half the product of the lengths of its diagonal. So same as number 3. So with that, let us just use our formula and then substitute the values. So since we are given the area, which is 96 square centimeters, our formula will be now 96 equals 1/2 times the length of OE, which is 3 centimeters, times the length of LN. Manipulating our equation, we will come up with 192 divided by 3 as the length of LN. Dividing these values, we will have LN is equal to 64 centimeters. Number 5. If the measure of angle OEL is 74, then the measure of angle NLO is equal to blank. Since triangle ELO is an isosceles triangle, given that EL and LO are congruent by definition of a kite, we can say that angle OEL and angle EOL are congruent. So with the blue markings in our figure, angle OEL and angle EOL are congruent, and the red markings indicate the missing angle, which is angle NLO. Therefore, angle EOL is equal to 74 degrees. Using the sum of the measures of the interior angles of a triangle, we can say that angle OEL plus the angle EOL plus angle ELO is equal to 180. Substituting the values, we will have 148 plus angle ELO is equal to 180 degrees. Manipulating our equation, the measure of angle ELO is now 32 degrees. The main diagonal of a kite bisects a pair of opposite angles. So this is just one property that we have a while ago. So applying this in our problem, we have angle NLO is equal to 1/2 of angle ELO. So with that, we will now have the measure of angle NLO is equal to 16 degrees. There you have it. I think it's just easy. Let us now have the summing up. In solving problems about kites, we have to remember the definitions and the following concepts. So, our definition of a kite is a quadrilateral with two pairs of adjacent and congruent sides. We also have opposite angles at the endpoints of the cross diagonal are congruent. Also, the main diagonal bisects a pair of opposite angles, and the perpendicular bisector of at least one diagonal is the other diagonal. And also, do not forget that the area of a kite is just half the product of the lengths of its diagonals. There you have it. If you have any difficulties in understanding the lesson, you can always do a replay of this video or check your modules about the concepts in our lesson. And if you have understood it very well, congratulations! You may now proceed with the answering of our practice exercises as well as the evaluation. Thank you and goodbye!